Well, hey there, folks. Elvis PEMDAS here, back talking to you about real numbers and the number line. Now, I got a question. Why did Elvis get arrested after the concert? Because he was in trouble. How?
First thing we're going to talk about is a number line. That's a line on which numbers are marked at intervals used to illustrate simple numerical operations. So here we have a number line and we are counting by increments of 1. And in the middle we have 0, which we are going to call our origin. The next thing we're going to talk about are natural numbers. Those are counting numbers that begin at 1 and they go 1, 2, 3, 4, and so on, all the way to infinity. These are also known as the positive integers. Integers we're going to talk about in a second. Let's just focus on natural numbers for right now. Those are just basic counting numbers, starting with 1. They're going to be on the right-hand side of 0 on our number line. It's going to be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now just because we stopped at 10 on this graph doesn't mean that's where natural numbers stop. They keep going forever. They go to 11, 12, 13, all the way to infinity. Those are natural numbers, starting with 1 and continuing in the positive direction. Whole numbers are just natural numbers and 0. So the only difference between natural numbers, counting numbers, and whole numbers are that whole numbers include 0. So we start at 0 with whole numbers, and then we do all the natural numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity. So again, whole numbers include 0. Natural numbers do not. Integers are going to be whole numbers, which we just said are 0, and then all of the natural numbers, and their opposites this time. So for integers, we're going to do all of the whole numbers, starting with 0. So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity. Integers include the opposites of these. So we also have to include -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, all the way to infinity this time. Those would be integers. Now, rational numbers are any numbers that can be written as a simple fraction, okay? So this is going to include natural numbers, whole numbers, integers, terminating decimals, so decimals that stop, that don't keep going on forever, and repeating decimals. Now, these would be decimals that do go on forever, but it's like 0.333333 or 0.25252525. Those would be included in rational numbers because those particular decimals can be written as fractions. So let's do some examples. First, -7. That is a rational number. Why is it a rational number? Because -7 can be written as a fraction, -7/1. It's also a integer. -3.75 can also be written as a fraction. It is a terminating decimal, meaning a decimal that stops. So we know that it is a rational number. 0.3 repeating. Again, it's a repeating decimal, meaning that it can be written as a fraction, 1/3. So it is a rational number. 1.5, that would be 3/2 or 3/2. Again, can be written as a fraction, therefore it is a rational number. 3, again, is 3/1. That is also a whole number and an integer and a natural number. And then lastly, we have 7.25, which can be written as the fraction 29/4. Again, it's a terminating decimal, so you know it's a rational number. Again, rational number, you see ratio, that is a comparison of two values or a fraction sometimes, so just think about that. Ratio means fraction, which means these numbers can be written as fractions. Now, irrational numbers are any numbers that cannot be written as a simple fraction. So these are going to include non-repeating and non-terminating decimals. So think about that for a second. A non-repeating and non-terminating decimal would be like 0.1738259. Continues on and doesn't repeat and doesn't stop. Another example of that would be the constant pi. If you've ever heard of pi, that's 3.1415926.5. That keeps going on forever and it doesn't repeat. Therefore, it's an irrational number. We also have square roots of non-perfect squares. Non-perfect squares. So not the square root of 16. Square root of 16 is just 4. That would be a natural number, a whole number, an integer, a rational number. If we want to take the square root of 17, that gives you 4.123. That is a square root of a non-perfect square, which creates a non-repeating, non-terminating decimal. Therefore, it's an irrational number. Now, real numbers include everything we just talked about. All numbers on the number line are considered real numbers. So instead of particular points on the number line, it's just everything on or between these given values. Here's a little diagram to show you what we're talking about. The most inner box here is natural numbers. That's the most exclusive. Outside of that, we have whole numbers, which include 0. So whole numbers include natural numbers and 0. Integers include whole numbers, which are 0 and the natural numbers. And they also include the opposites, right? -1, -2, -3, ... Rational numbers include integers, whole numbers, and natural numbers. Irrational numbers are numbers that are not included in any of these categories right here, but are still included in the real numbers category. Real numbers include each of these categories.
Why did Elvis go to the farm? To look for backup musicians. Example time.
So example 1 says graph the numbers on the number line. So we're going to start with 7. We find 7 on the number line. Here it is. We put a little point and we're done. -6. We're going to plot that on this number line. We go over to -6. We put a point and we're done. 4.5. How do we graph that? Well, there is no 4.5. There's just a 4 and a 5. So what we're going to do is we're going to go halfway between 4 and 5. We put a point and we're done. -37/4, or 37/4. How do we figure out what that is? Well, first, let's figure out what that is as a decimal in order to plot that. 37 divided by 4 is going to give you -9.25. Now that we know it as a decimal, it's a little easier to graph on our number line. We go over to -9, and now this number is going to be between -9 and -10. But since it's -9.25, it's going to be a little bit closer to -9 than -10, so we're going to put it right here. Next, we have -1/3. Now, -1/3 is between 0 and -1. From 0, it's a third of the way to -1. So we go a third of the way to -1. We put a point and we're done. 9.5 is 9.5. So we go right smack dab between 9 and 10 over here. We put a point. 5.9, it's super close to 6. So we're going to put a point very, very, very close to 6, but not quite. And then the square root of 3. Okay, we need to figure out what that is. So we put that in our calculator. We get approximately 1.73. So we go over here. That's going to be between 1 and 2, and it's going to be close to 2. So we put our point here, and we're done.
Did you know that Elvis recorded over 600 songs and didn't write a single one? I bet you didn't. See if you know this.
All right, let's do this. So we have 4. We find 4. We put a point right at 4. Easy. -2. Same thing. Go over to -2. Put a point. Done. 8.5 is going to be halfway between 8 and 9, so we put a point here. -15/2, or -15/2. Now, what is that? If we were to divide that in our calculator, we get -7.5. So we go over to -7, and -7.5 is going to be halfway between -8 and -7. So we're going to put that point here. -1/4, that is going to be between 0 and -1. Again, that's going to be a fourth of the way from 0 to -1. So we're going to put that around here. 7.4 is between 7 and 8. So we're going to put that almost halfway. 5.6, it's going to be basically in the middle, but a little bit closer to 6. And then rad 5, we put that in our calculator, we get approximately 2.24. So we find 2, and it's going to be between 2 and 3, but it's closer to 2 than it is to 3. So we put our point here, and we're done. Okay, example 2 says name the set or sets of numbers to which each number belongs. We're starting with -4. Now, you see that negative? Right away, you should think, okay, negatives start with integers. And since this doesn't have a decimal on it, and it's not a fraction, we know that it's going to be an integer. Next, since it's an integer, we remember that chart that we had before, that diagram. Integers are included in the set of rational numbers because this can be written as a fraction, -4/1. We also know that since it's an integer and a rational number, that those are included in the set of real numbers as well. Any number that we're going to talk about today is a real number, so that would fall under this category as well. 1/5, that is a fraction, that is a ratio. So right away we're thinking rational numbers. Okay, so that's going to be the first category. It can be written as a fraction. We know it's a rational number. And rational numbers are included in the set of real numbers because we said everything we're going to talk about today is a real number. The square root of 6. 6 is not a perfect square, so we cannot take the square root of this without getting a non-repeating decimal. Therefore, this is going to be an irrational number. And since it's an irrational number, we know that's also included in the set of real numbers as well, and you're done. Lastly, we have 0. 0 is not included in the set of natural numbers, but it is included in the set of whole numbers, right? Whole numbers are just natural numbers plus 0. So we have whole numbers. We know whole numbers are included in the set of integers, which are included in the set of rational numbers, which are included in the set of real numbers, the overarching set of real numbers.
We'll be dancing to the jailhouse rock. Jailhouse rockin', cause that's how the song goes. You try.
Okay, we're doing the same thing. So here we have negative pi. We talked about pi earlier. Pi is an irrational number. Now, even if it's negative, it's still just a negative irrational number. So it's an irrational number. And irrational numbers are also included in the set of real numbers because those are all the numbers we're going to be talking about today. Negative 5.7. This is a terminating decimal, a decimal that stops, meaning it's going to be included in the set of rational numbers. And now rational numbers are also included in the set of real numbers, and you're done. Part C, we have negative 40 over 5. This is written as a fraction, a ratio, which we automatically think rational numbers. However, we can divide this. Negative 40 over 5 is going to be equal to negative 8. Now, this no longer is a fraction, right? It's still a rational number, though, because it can be written as a fraction. Because it reduces to negative 8, this is now no longer just a rational number and a real number. It's also an integer. So we have integers, we have rational numbers, and we have real numbers. And then 2. 2 is going to be included in everything. It's a natural number, whole number, it's an integer, it's a rational number, and it's a real number. Example 3 says, are natural numbers, whole numbers, integers, or rational numbers the most reasonable for each situation? So we're going to talk about specific real-life situations, and we're going to classify them based on what category they fall into. So your height.
Now in the US, your height is typically given in feet and inches, where an inch is 1/12 of a foot. So if you say that your height is 5 feet 7 inches, you're really saying your height is 5 7/12 feet tall, meaning that you're writing your height as a mixed number, which can be written as an improper fraction. And because it's a fraction, we know it must be a rational number.
Your age. Most people just give a specific counting number for their age. Now, sometimes when you're a toddler, you say like I'm 2.5, 3.5, but most people just give a specific counting number for their age, right? Nobody says they're 0 years old either. It most likely would be a natural number for your age. The temperature on your weather app. So that usually comes out as a positive or a negative number if you live in some cold places. So we can have positive or negative numbers, and they don't usually give you decimals. So what we're going to say is integers for this one. And then the number of cousins you have. You can have 0 cousins. You can also have 1, 2, 3, 4. You can't have negative cousins, and you can't have fractions of cousins. So we're going to say that whole numbers would probably be your best bet.
Ho ho ho! I'm the king. You try.
So we start with how many pizzas you bought today. Now, can you buy half of a pizza? You can buy a slice of a pizza, but usually if you're talking about whole pizzas you bought, it's going to be 0, 1, 2, 3, 4, 5. Starting with 0, meaning that it's going to be a whole number. So we're going to talk about whole numbers there. How much of a pizza you ate at dinner. This is where we get into slices or fractions, right? So how much of a pizza did you eat? You ate half, you ate a third. These are fractions, so that's going to be rational numbers. How many steps you took today? You can't really take half of a step. You can take 1 step, 2 steps, 3 steps, 4 steps. It'd be really hard to take 0 steps, but technically you could if you just laid on the couch all day. So we're going to say whole numbers. And then how much debt you have. This can be money, which has cents attached, right? So there is a decimal and it's a terminating decimal. So we're going to say rational numbers as well.